Okay, so we're getting started. Today we're looking into the applications of logarithmic and exponential function. We're looking into the exponential models which used to model usually growth and decay. But first we will start from finding the rule. If we have the rule, like we have 2 points and we need to find the rule of exponential function. So it's exercise 13H, and we'll do example 13B. So we have that exponential function is of the form y equals a times b in the power of x. And we have 2 points, 2, 1, and 5, 1, 8. And we need to find the rule, we need to find a and b. So what we need to do? Substitute points. So let's substitute first point. We get 1 equal a times b squared. And second point we have 1/8 equal a times b in the power of 5. So we've got 2 simultaneous equations. In this case, what will be the best way to solve them? Divide. So let's divide equation 1 by equation 2. Equation 1 divided by equation 2. Why are we doing that? Because in this way we will eliminate a. When we divide, a will cancel out. So 1 divided by 1/8, we get 8 equal b in the power negative 3. So what b will be equal? One half. It will be 1/2. If it will be b in the positive 3, then it will be b equals 2. Because it's negative 3, b equals 1/2. Then we substitute it into, let's say, equation 1. We get 1 equal a times 1/2 squared. So a equals 4. A equals 4. So the answer is this exponential function is y equal 4 times 1/2 in the power of x. Make sense? Pretty straightforward. Always when you have 2 points, you need to find 2 unknown. You sub in one, sub in another one, and you solve the simultaneous equations. Now, another example. Let's consider exam application to physics to the radioactive decay. When there is such thing as half-life for radioactive decay, that means it's a time over which half of the radioactive material decay. So, question 2 from the same exercise. Half-life of plutonium-239. Plutonium-239. Half-life is capital T. For half-life, we will use capital T to distinguish from the running time. Is 24,000 years. That means that over 24,000 years, half of the plutonium will decay and will turn in some other chemical element. Yes?
What is that 2 then?
That's
Question number 2. It's from the exercise 13H, question number 2.
I wasn't even clarified.
So, we have now at the start we have 10 grams of plutonium. We have 10 grams. Question is,
OMO.
how long it will take until only 10% will remain undecayed.
That's good. That's a good
10% will remain. So, what is 10% of 10?
question.
1. So, the equation, in general equation of the radioactive decay is M, mass that we have now, equal original times 2, because it is half-life. So, it's every period of half-life, it becomes twice less. Time in the power negative t over half-life. This is a formula that means every half-life. So when we have time equal half-life, what we will get? That will be 2 in negative 1, so we divide by 2. When we have time equal period of half-life, we will get mass equal m0 times 2 in negative 1, so equals 1/2 of m0. Over half-life, we have only half left. Now, if t equals 2t, if time equals double that period,
We have 1.
m equal m0 times 2 in negative 2t over t equal m0 times 1/4. So after 2 half-lives will be 1/4. How much will left after 3 half-lives? 1/8. And so then 1/16 and so on. So every time when another half-life passed, half of what we have decayed, so half left. You divide by 2 every time. That's why it's called period of half-life. Now, we have originally 10 grams and 10% left. 10% of 10 is 1. So we have equation 1 equal, that's what we have at the end, 1 gram, equal original amount, 10 grams, times 2 in the power, we look in t, and we have 24,000. It's given that the half-life is 24,000 years. So, rearranging this equation, we will get 2 in the negative t over 24,000 equals 0.1. Make sense how I got this?
Yes.
I just moved 10 to other side.
He said the equation.
Where's the little t coming from?
The little t is time. The amount of
A little t,
trying to find the amount of time.
t is the running time. It's any time. In this way,
Little t is x.
Sometimes I'm confused.
in this way, we can find after this time how much left. That's how much we have at the beginning, and it's decaying while time is running, and we can calculate how much left at any given time.
But don't know that m is 1.
It was given to us that originally we have 10 grams,
Yeah, I want only.
and only 10% left. What is 10% of 10? Is
So we know
1.
that m is 1.
So we have 1 left equal original 10 times 2 in negative unknown t, that's what we need to find, how long it takes, over period of half-life for plutonium is 24,000. Now, how we've solved this?
You just divide by 10. Both of you divided by 10.
No, this one I've already divided by 10, but this, how we solve this? Log, we need to use log with which base? With the base 2. So we get that negative t on 24,000 equal log 0.1 with the base 2. So time will be equal negative 24,000 times log 0.1 with the base 2. Use a calculator, use CAS calculator to calculate what number is that.
How use CAS like in the first equation as well?
Yeah, you can use solve, but here not solve, function.
Yeah.
So just calculate what this number will be.
Because that's to
Oh,
get
that's
the-
all.
Because in the
This is
CAS
the
calculator you can
Yeah.
choose log with any base.
So this is the
As a
exact-
difference to scientific calculator. Have someone calculated?
Yeah.
What?
79736.
0.274.
779
Yep, 726.
726
.274.
274. Now, because question asked, this is important. Because that's not a final answer. Question asked, I should give your answer to the nearest year. And it says, how long will it take until only 10% of the original sample remains? And give give your answer in years. So what should be our answer? It should be 79,726
No,
27.
27. Why?
Because it won't be
Otherwise-
79.
Because at 26 it's not
It's above 10.
1 gram. It's more than 1 gram left.
Yeah.
So will be less than 1 gram left at 79,727 years. That will be the answer. That's no. Plutonium has quite long time half-life. There are some elements which decay in the second, even not seconds, in the like microseconds, or even less in the 1 millions or billions of seconds. Some decay even slow. For example, uranium has half-life of 4.5 billion years, which is about the age of our planet. So that means we have now, if we have that age of the Earth is 4.5 billion years approximately, and half-life of uranium-238 is 4.5 billion years. What fraction of uranium we have now compare how much it was when the Earth was made? We have the age of the Earth. Age of the Earth is 4.5 times 10 in the power of 9 years. And half-life of uranium-238 is the same number.
Exactly half.
So, how much uranium left now? Half, yes. After one half-life, there will be half left. So now we have half of uranium that was when planet Earth was created.
When is the uranium?
Okay.
It becomes not uranium.
By the way, in second semester in physics, we're doing astrophysics, and we will learn like
Feel bad.
things that, for example,
3.5 lives.
uranium
It's like a full life.
Uranium and any
Right.
uranium and any chemical element beyond iron can be created only during explosion of the supernova. So effectively, Earth and we all made from the stardust, from what's left after the explosion of supernova. And that's what will be part of what we will be learning, who will choose physics for semester 2. Another example. Now, often exponential functions are used to describe population models. For example, question 5. So 5 is a number of the question in the exercise.
That's right.
So, biological culture contain 500,000 bacteria. So, initially there are 500,000 bacteria. at 12 p.m. 12 p.m. on Sunday. And culture increases by 10% per hour. 10% per hour. Every hour, number of bacteria increased by 10%. Question is, at what time there will be more than 4 million bacteria? So we need to make mathematical model describing this process. So number of bacteria will be equal number of bacteria of the beginning times what? If it grows by 10%. 1.1 times 1.1 in the power of t, where t is number of hours. Does everyone understand why it's 1.1? In the power of t. So now we have 4 million, we need to find t. We have 4 million
The base.
equal, originally we have 500,000 times 1.1 in the power of t, divide, so we have 8 equal 1.1 in the power of t. And again, we will need to use log to solve it, so t will be equal log 8 with a base 1.1. Again, please use your calculator to calculate the number. Calculate the number. 21.8. 21.82. Now, this what we have found.
The exact amount of
We found number of hours, how long it will take, amount of bacteria to increase from 500,000 to 4 million. But question does not ask after how many hours. Question asks at what time.
10 a.m. on Monday.
We start at 12 p.m.
Yeah.
So what we need to add to 12 p.m.? Which number? 22. Because if we add 21, they don't yet exceed 4 million. So 12 plus 22, we have 34 minus 24. So when it will be? Answer will be 10 a.m. 10 a.m. Monday.
Oh yeah, yeah.
Explain this so much more.
So answer, proper answer will be 10 a.m. Monday. So amount of bacteria will exceed 4 million at 10 a.m. Monday. So remember that this is not what question asks. You need to answer what question asks. Make sense?
Yeah.
Of course, and it equals 8. And it's 8
I'm showing you how actually do.
Give me a second, I need to mark the present.
Mystery.
Yes. Okay, one more example. Okay. One more example. One more example, and then you will be working on the question. It is question number 12.
Yeah.
Question number 12.
And a cup.
A cow.
Yeah. Didn't get hit in the nuts. It's to protect your colonial bloodline.
Leon, you're broadcasting now.
Wasn't it
12. Question number 12. So, So company begins, no, actually 11. Better do 11 question. 11, I like it more. Question 11. Object is falling.
10 a.m. on Monday.
Object is falling such that its speed v
9.8.
changes according to the next model. 80 times 1 minus 3 minus 3 in the power negative 0.05 t.
Are you gonna cook today?
So that's how the speed of the
I'm gonna.
that's how the speed of this falling object changes.
Okay.
So, and question first, A, determine the limiting speed.
This is 1/2.
Limiting speed. To understand why there will be limiting speed, let's sketch this graph.
Okay.
So, without any numbers yet, but just how it looks like. So to do this, let's expand the brackets. We have 80 minus 80 times 3 in negative 0.05 t. Compared to the graph, y equal 3 in the power of t. What transformations are here? What is this?
Reflection.
In reflection in x-axis. What this minus does? In y-axis. This
Dilation by
from x-axis, and this translation 80 up. So if we have graph 3 in the power of t, that will be the graph. We have its graph reflected in x-axis, then it was reflected in the y-axis, and then it was dilated. It was dilated times this by 80, so this becomes from 1, dilated becomes 80, this point, and we move it 80 up. So our final graph will be, what will be the asymptote? 80. So we have asymptote at y equals 80. And now, should we sketch the graph for negative values? No, because it's time. It starts at 0. And what will be, because this point was negative 80, 1 minus 1 after reflection times the negative 80, and v plus 80. 0. And that will be how the graph will look like. And as y equals 80 is asymptote, what will be the limiting speed? 80. So it will be falling, its speed when it drops something near the earth. It's falling with acceleration. Initially 9.8 meters per second squared, but while object falling, its acceleration will be decreasing. Why? Gravity does not change. Air resistance. And air resistance increasing with the speed. The faster object moving, the more air resistance. And at some stage, air resistance will become equal gravity, and that will be limiting speed, or so-called terminal velocity. So object will be falling with a constant velocity. So that we answered part A. Yes?
So limit is just another word for asymptote in this context.
Yes. And limit we will learn as a mathematical operation in term 3. We'll learn what does it mean limit. Yes, that will mean something approaching. And part B asks, when does the object have speed 40 meters per second? So we need to substitute 40 in the equation. 40 equal 80 times 1 minus 3 negative 0.005 t. So divide both sides by 80, 0.5 equal 1 minus 3 negative 0.005 t. So we have negative 0.5.
It's 1 0.
As in negative.
Sorry. So negative 0.5 equal 3 in negative 0.05 t. So take log with the base 3 of both sides.
Mr. V, where did the 1 go?
1, sorry, it's minus here, so minus cancels out.
0.5 minus 1.
Yeah, and so we have that negative 0.05 t will be equal log of 0.5 with the base 3. So t equal, t will be equal negative 20 log 0.5 with the base 3. Why it's 20? How I got 20?
Divide by that in times by 20.
1 divided by 0.05 equal 20. And then you put it into the calculator and also it's asked question, sketch the graph, but we started from sketching the graph. Any questions? Okay, that's all, pretty much that's all for the topic, exponential and logarithmic functions. So from now on we will be just practicing and prepare for the test, which will be next Tuesday. Like, subscribe and donate to help fight terrorist countries and organizations like Russia, Hamas, Iran, etc. Support Ukraine and Israel.